Guys want to mute your phones while I do the intro? Welcome to our show, How to Use 3D Printing in Your Business, which is sponsored by Kathy and the team at ISM New Jersey. I'm your host, Sarah Scudder. I'm a growth strategist and help B2B tech companies with their marketing. I oversee marketing for Real Sourcing Network. We also go by RSN, and we provide an innovative and painless way for companies to buy high quality print and packaging for less. We help companies design, re-engineer, and source their packaging. Something that's become of interest to our team is the rise of 3D printing and how it can be adopted by companies. 3D printing is the process of producing three-dimensional objects from a computer file where the part is built by adding material layer by layer. 3D printing represents many significant advantages over the more traditional manufacturing methods of subtractive manufacturing and objective molding. And there's a couple benefits of 3D printing that I want to highlight that I think are really, really important to companies that are thinking about maybe testing out or trying 3D printing for the first time. And the first is speed. Speed has improved, though they are not suitable for mass manufacturing projects. So we've seen significant improvements in speed, but if you're wanting to do significant volumes, still not there yet. They're well suited for applications where small volumes of unique parts need to be created for prototyping. Second is costs. Costs are far more affordable than when the technology was first introduced. So when 3D printers first came out, they were pretty expensive and cost prohibitive unless you were a really large organization or company. The third is flexibility. A printer can create almost anything that fits within the build volume. So you can have very unique, obscure sizes for things that are produced with 3D printing. So joining me today is Roger Buck and Nick Zeid. Roger is a dear friend of mine. Him and I have both worked in the printing industry for many years, and he's kind of my go-to whenever I have a question about something related to printing. And Nick is going to be running our show and tell today, and he actually works at a company in the 3D printing space. So he is our 3D printing expert. So I want to start us off, Nick, by having you introduce yourself, share an interesting personal fact, and then a favorite 3D printing story. And I know you've probably have a lot of stories that you've come across, but something that was really, really unique that stands out.
Okay, I'll do the best I can. So my name's Nick Zeid. I work for Computer-Aided Technology. I've been with our company for about 10 years now. CATI is known as the nation's leading provider of product development solutions. We help customers get to market faster and improve their processes and workflow. Something maybe interesting about me, even though I've been tapped the 3D printing expert today, I majored in college in finance and real estate. So it doesn't take a degreed engineer to be a 3D printing expert. My story that I wanted to share with you guys is I think a lot of people think prototyping with 3D printing, they think end use parts, they think toys and trinkets, maybe like this little guy. We talked about the Mandalorian, I think a little bit on LinkedIn earlier. But one of my favorite things is what we're doing with the hospitals. So here in St. Louis, we work with the St. Louis Children's Hospital and Cardinal Glennon Hospital, and they're actually printing 3D printed hearts and anatomical models for their for surgical planning procedures, right? So you could have a child with a small tumor in their brain, and you can print the model. This is a heart model that I'm going to show you here, but you can print the model and get the feel and the touch of what that procedure is going to be like, and the surgeon can plan accordingly. Maybe develop a new path to that surgery, as well as educate the parents or the patient or whatever it may be. So what we're doing on the medical side has been really revolutionary.
So Nick, I feel like my mind is kind of blown at imagining people actually creating human parts from a 3D printer. It's something I feel like I can't even grasp and get my mind around, and would be really cool to see that actual in real life with somebody actually using one of those parts. So
Yep.
I'm looking forward to seeing some more of those examples that you're going to share with us.
Absolutely.
Roger is joining us from the car today. He's been driving for 5 hours for a meeting, so super excited that he was able to spend time with us on his drive. So Roger, would love to have you introduce yourself, share a fun personal fact, and then one of your favorite 3D printing stories.
Okay, super. Well, my name is Roger Buck. I've been in the printing business for about 50 years, all different facets of it, and still having a lot of fun. And I tell everybody that if I've got a nickname, it would have to be I'm a millennial trapped in a baby boomer body, because I'm still so excited about this business. The quick fun fact was, if you would have seen me 50 years ago, you would have seen hair down to about the middle of my back, and I was playing guitar in a rock band. But then I got into the printing business and all went to the side, so I'm doing a lot more fun. My 3D story, I'm going to give you about a 15-year storyline in about 2 minutes. The first time I was really introduced to a 3D object that I got to see done was at a distributorship in Chicago I was visiting. And this particular distributor did a lot of work in the promotional product area. He sold what we used to call trinkets and trash, little things you'd pick up at trade shows. But he had decided to specialize in things that you could not buy. He wanted to be able to offer somebody something that they could give out at a trade show or send to a client that was unique and nobody else had. He actually went out and invested $50,000 in a 3D printer. And when he came up with an idea for a new widget, he would give it to his CAD drawing guy. They would put it into the CAD system. They would draw it. They would send it to the printer. And within 24 hours, he had one of these made that he had dreamed up the night before. And he would take that out to clients around Chicago and try to sell it and find an order. When he found an order, he would then take that design to his injection molding friend, and they would actually make 100,000 of those pieces that he would sell. So he was offering something, a very unique service that he would dream up in the shower in the morning, and 24 hours later, he's showing that prototype, all because he invested $50,000 in one of these 3D printers. Now I'm going to fast forward about 10 years. I'm in St. Louis, and I happened to meet this company called Computer Aided Technology, and they introduced me to the Stratasys line of printers that they were selling. And they were nice enough to give me a quick tour of their operation. And I saw that instead of using the powder system that my buddy in Chicago used 10 years earlier, this has now moved to monofilament, like weed eating line. There's a monofilament line, but they can use more than one piece. So now they're doing it in different materials, and they're doing it in colors. And I'm thinking, this is light years. This is like Star Trek stuff. This is so cool. Now, fast forward to yesterday. I go down, and Nick is nice enough to give me a visit down at his office, and he showed me the equipment that you're going to see here in a little bit. And he shows me this room full of things that they have done on these 3D printers, like the heart, like, dentures and things like that. Absolutely blew my mind. I thought I knew what 3D could do and where it's immersed to. Not even close. So you're really going to enjoy this. They've got some very cool technology. The thing that really impressed me was the part that my buddy produced in a machine that he spent 50 grand for. You could probably do in a $12,000 unit today and have a better piece and do it in color. So it's just the technology has migrated so far in the last probably 10, 15 years. It's just amazing. So I'm going to shut up and turn it over to Nick, because you folks have a lot to see, and he's a wealth of information. So Nick, take it away, my friend.
Thanks,
Thank you,
Roger.
Roger.
Nick, quickly before we get into the show and tell, for those that are with us today, this is meant to be interactive. So please feel free to use the chat function at the bottom if you want to put any notes or comments for Roger or Nick. And then there's the Q&A function as well. So feel free to ask Nick any questions that you want about the actual printers themselves, or some of the examples that he's going to share about things that they've actually created with the printers. This is a really unique opportunity to get up close and personal with an expert in the 3D printing space and talk about how this may be something that you can use either personally, where you can buy printers for a couple $100s now and do things at your house, or things that you can use on a much larger scale in your businesses. So with Nick, would love to turn it over to you and have you kick off the show and tell and talk to us about the actual printers and how they work.
Yeah, absolutely. Thank you very much for the introduction. So we are in my office. I'm in St. Louis today, and we've got offices throughout the country. We're in our showroom. So I've got 5 printers in the room that I'm in right now. I've got 2 that are PolyJet technology, and I have 3 that are FDM technology. Those are probably the 2 technologies that we're going to talk most about today in regards to 3D printing. There are other technologies out there that are SLS or SLA or SAF technology. Stratus has introduced a new technology, a P3 technology, that's DLP. And those are printing. We talked a little bit, I think, earlier in the conversation, is we're not at mass production yet, but some of these new technologies that are being released are getting us closer and closer to that. We're going from short run production of 100 to 1,000 parts to 10,000 to 100,000 parts, depending on the geometry and the size and the material. That's a possibility now. So it's really exciting times in the 3D printing world. But I've got a colleague of mine, Nathan. He's going to be with me for about 5 to 10 more minutes. We've got a tripod camera on the table here. So we're going to try and just walk the camera over and show you some of the printers while I've got some assistants. And then you guys can see these printers in action live. We'll talk through a little bit of the technology and hopefully have some questions to address for you guys as well. So Nathan, if you want to walk the camera over here, you've got a much steadier hand than me. So maybe start with the J735, if you can see this. Maybe lower just a little bit. Yeah, so this printer is printing currently. Well, we'll just leave it run that just so they can see it. Then we can show what that looks like, then we'll talk about it afterwards. So this is a new printer, and it kind of looks like a jukebox. Beautiful colors, and it's just finishing up. So one of the things that we'll be able to do also is just show what it looks like when a job is finished, taking parts off of a machine, and what the post-process looks like. So over here, different technology. This is an FDM printer. This is a filament-based printer. I think this is something that more people will be familiar with as far as the technology goes. It starts with almost like a weed whacker line, and it's extruded through a print head. It's heated up. It's almost like a hot glue gun. You're basically drawing your parts one by one with a printer like this. And same thing here, just a smaller version of this. FDM printer also running right now. Go over there. Okay, I think that's good. Perfect. Thank you. And then if you want to show just the samples over there. Good enough. So we'll start with the printers that I showed you first. These would be the PolyJet printers. This technology has come a really, really far way. What we see most applications with PolyJet printers would be concept models, front-end prototyping, maybe some functional prototyping as well, but the material strength isn't as strong as what we have on our FDM technology, but you're getting highly accurate parts. We're printing at 28 micron layers. That's like the size of a human hair. And you're getting almost an injection molded like finish. When this technology came out 10 years ago, we were only printing one material at a time. We've gotten to the point where we're blending up to 7 different model materials. We can blend rigid and flexible materials. We can blend colors. The printers are Pantone validated. If you wanted to print Pantone 224 color on a part, you can do that and call it out. So what I'm going to show you here is just a few sample parts that come off of this machine. All of these are printed in at once. They're not assembled together or anything like that. So this, just a little, we talked about trinkets earlier, this is just a fidget spinner, right? But all of that was printed at one time. This is a little bit more design realism, a donut. I think this part's amazing. The color, the texture, everything about this looks like a real donut. Again, all printed at once. I know I showed this briefly earlier, but this is our baby Yoda that we printed. I think we had some hopes to seeing a Mandalorian helmet at one point. We don't have a Mandalorian helmet, but this is as close as I get with little baby Yoda. And here's an example of, and might be hard for you guys to tell, but this is an example of blending two different materials, a rigid part and then a part that's flexible at a Shore 30A. So you can blend these to come up with different durometers throughout the part. And this is all printed at once. So you're slowly working up to a Shore 90, 85 to 90. You can control overmolding and everything like that. And then this would be another kind of example of doing a texture wrap. But for industrial designers, what we're able to do from a consumer good type applications in those marketing meetings, being able to go to a meeting and have, let's say, 5 different versions of this, maybe in different colors, maybe in different feels, and pass that part around to everyone before going to tooling and going to production, making sure you've got the right fit. That's really what something like this offers. On the polyjet.
Nick, a couple questions about what you just showed us.
Yeah.
How long would it take for somebody to create some of those things?
Sure.
Because I look at that and I think, wow, like that's amazing. I mean, that donut looks like a real donut. You know, are we talking about hours? Are we talking about days?
It depends what kind of software you have. So some printers out there, the printers that we work with for stuff like that, you can use a software like Keyshot. So there's other rendering softwares and imaging softwares that help with the texture, just like something like this. So you still need to design everything that gets 3D printed. There has to be a 3D CAD model to 3D print something. That's where we generate all of the, call it quote unquote tool paths, right? To print these parts. We can't 3D print something from a 2D CAD file or from a picture or from a 2D drawing. We have to have 3D CAD before we get to a 3D printed part. And it just, you know, something like this, I think this could take a few hours to design, right? Or maybe if you had a 3D scanner, you could scan this and import it and save it out as a step or an IGES file and send it directly to a printer. So there's a number of different ways. It's hard to say specifically, I think, how long it would take something.
But can you give us an idea of excluding the CAD drawing process, what the print time might actually be for something like that? Because I saw that donut yesterday and it looked edible.
Yeah, right. I wanted to actually, I didn't have time this morning, but I wanted to go to the bakery and grab some real donuts and see if you guys could see the difference between this and a real donut. So, you know, I think something like this, it's really about the Z is what increases the time on at least the PolyJet technology that we're showing you guys today. I think this is probably like a 3.5 hour part, maybe 4 hours. Now, the thing that's interesting, and I don't want to get too into the weeds here, but on the PolyJet technology, the print head is going all the way down the length of the build envelope and then back. And then it indexes down, it does that middle part of the build envelope, indexes down, it does the front. But every time it goes to the end of the build envelope, if that makes sense. So if this is in just the first path that's going down and back, this part might take 3.5 hours, we said, right? But if we added a second one, the print head was already moving past it So it might only take 3 hours and 45 minutes to print 2 of them. It might only be 4 hours to print 3 if they all fit in that path. So you're not exponentially increasing the print time as you're adding parts to a PolyJet 3D printer.
Now, Nick, the PolyJet 3D printer, how many items can it produce at once that are a different design? Is it one design per run, or could you be producing some of those things that you just showed all at once?
Yeah, great question. So you can print as many different types of parts on one build tray as will fit on that build tray, and then you'll just be limited, if you want to say limited, to the materials that you have installed in the machine itself. So we got 7 different materials loaded on our J8 series printers. That gives you the ability to print a cyan, a magenta, yellow, black, white, clear. That basically gives you a full Pantone capability. So you can put a flexible material in there as well. So you still have room for all of that. So you really could print one of these and one of these and this little wrench. Print them all at the same time if they all fit. You could print this heart model as well if you weren't using the digital anatomy materials that we have, because we've got hospitals that are just using our standard printer without the digital anatomy capabilities, because you can still blend the flexible and the rigid materials to come up with a variety of different durometers to simulate some of those cases that they're working on. So yeah, there's no limit to the number of parts and the different geometries in a build envelope as long as they fit.
So Nick, for those who are with us today or maybe listening in later, how much are we talking about in regards to buying one of these printers and then maybe some of the software that's associated with it?
Great question. So if we want to just print one material at a time, and we're talking PolyJet technology still, those machines start around $20,000 or $25,000. Once you start introducing color and blending materials together, you jump to $60,000 to $70,000 to $100,000, and then with a full big build envelope, say 20 by 15 by 8, with all the color capabilities, you could be in the $250,000 to $350,000 price point.
So we're talking about an entry point for that specific machine around 25K, all the way up to around 300,000 if we wanted absolutely everything.
Mm-hmm.
Nick, have you seen any case studies or real life examples of how much these printers have saved companies? Because I know organizations that spend significant money dealing with China and overseas productions for prototypes, and this could be a huge saver for companies to actually invest in this themselves. So I actually see it as a really cost-effective alternative.
Yeah, absolutely. So I think one way to look at it is on the tooling for injection molding. If you're an injection molding company, and you're traditionally designing a part and then designing the tool, and then you outsource that tool, whether it's here locally or overseas or wherever it may be, you could see a 6 to 8 week lead time or 3 to 4 month lead time, right? And that tool is expensive. It could be anywhere from $10,000 to $50,000 to, it could go up from there, right? What we end up seeing is you get the tool back after 6 months or after 3 months, however long it takes, and you've spent $50,000 on it. You shoot your parts, and all of a sudden something's not right. The part doesn't fit the way it's supposed to fit, right? Right there, that's how you justify a piece of equipment like this. And then in addition to that, with the color capabilities, with industrial designers and everyone really wanting to get their hands on what products are going to look like, and being able to design and iterate faster. If you can walk into a meeting with 5 different iterations of this design and pass them all around, and you came up with those designs on Monday, you send them to the printer on Tuesday, and you're meeting with those parts in your hand on Wednesday, you can make a much better educated decision on the direction you want to go, and in turn get to market faster. So
Yeah, so Nick, my boyfriend is a PhD material scientist. He works at a very large government lab here. They have about 2,000 scientists on staff, and 3D printing has been a game changer for them. So when you're dealing with certain types of science, you need to do a lot of prototyping because you need certain parts and materials to work on experiments. And so they were having to significantly delay projects and research because it would take so long to get the prototypes back. Now with 3D printers, they can get the parts that they need for their different projects or experiments in the same day. So they've invested heavily in 3D printers, and their lab will continue to do so.
that's amazing. And I think something to follow up on your material comment, and there's a ton of science behind all the different materials that they work with and they use. The same thing goes for 3D printing. We don't just magically say, we love this material, we want to print it, and then the next day we're printing with that material. There is a ton of research and development that goes into getting these materials, and figuring out, quote unquote, the right recipe for them to print reliably and successfully in at least the printers that we offer. We spend millions of dollars before we bring a material to market, especially on the other technology we're going to talk about, FDM. We're using true thermoplastics. And every material, whether we're printing an ABS or a polycarbonate or an Altem, there's a certain humidity temperature in that oven, and there's a certain temperature, a certain humidity that we're kind of controlling that environment to make sure we can print successfully.
Yeah. So Nick, let's go ahead and talk about some of I know we just focused on this one printer. Let's talk about some of the other printers that you guys offer.
Yeah, so the other printers are I think they were the three that we showed you second on the tour, but this is an FDM-based technology. And Roger kind of alluded to how it works, but we're using, it looks like a weed whacker line. It's a line of filament. We're using true thermoplastics. Our entry-level machines start with ABS thermoplastics, but it goes through a tube and a line, and it's extruded through a print head that heats up and extrudes that material at the top of the printer. And you're basically drawing your individual parts. It's almost like a hot glue gun, glorified hot glue gun. You're drawing your parts, and you're going one by one and drawing the parts like that. But these, we've got much higher end material capabilities from the stance of tensile strength, from heat deflection. So is on the PolyJet technology, these are beautiful, smooth, injection molded like parts. The FDM parts, you might not have the same surface finish as you see on the PolyJet parts, but you're getting much more robust parts that can get beat up a little bit more and have more applications. So we can do real functional testing with these parts. You can use them for a variety of different jigs and fixtures on the shop floor, and assembly aids and end of arm tooling, in forming tools, whether it's thermoforming or hydroforming. So there's a number of additional applications that we can leverage with FDM if you're okay with not having a glossy, very smooth surface finish, which for those types of applications that I just kind of talked through, they're perfect. So I have some examples of some FDM parts here. This is just to show the different fills that you can print with FDM. So that could be the inside of the part as well. So if you wanted to reduce weight or reduce material, you can see just less density fills and then solid fills as well, right? And then we've got raster fills around some of these holes, and then contour circles. So if you wanted to tap holes or put in metal inserts, instead of having a raster fill, you might make 3 passes in a circle around that hole to make it easier to use. This is an example of just some of the different surface finishes, and it's going to be hard to see, but I think you can see compared to some of the other parts you saw earlier, you can see a little bit of layer lines, and then again, just the different fills that you have on the parts. I think you guys, we've got a little bit of packaging in the background of your guys' group here, if that's correct. So one thing I wanted to show is, we do a variety of different thermoforming applications. This is a paper pulp mold thermoform. So we 3D printed this part in polycarbonate. And if you look closely, you can see our FDM material is naturally porous. So it's naturally going to pull a suction, which is great for forming applications. So this would be an example of just pulling the suction. Maybe you do that instead of going to a steel tool and drilling holes in that traditional way. You can do it on the front end with a 3D printed part. Let's see.
So Nick, we've got a couple questions coming in from the audience. So as you're getting your additional pieces together, Ernie, thank you for being with us. Ernie is awesome. So his question is, there are definitely some expeditionary supply chain applications here, spare parts for maritime ships, military, space, etc. Besides donut replicas, what are some of the most popular applications that you're seeing this year? So in 2021.
On the spot. Simple things like little brackets, right? You've got a lot of old machine and equipment out there. So replacement parts for some of the old machines and equipment that are in the field that they can't get service work done on or can't get replacement parts for. It's hard to just pin things down with just one type of application. You're seeing a number of companies still continue to upgrade their shop floor and bring in 3D printers to help just with jigs and fixtures and tooling, instead of traditionally using a CNC machine on like Delrin material, right? You can 3D print a material that's very similar to Delrin and get the exact same use and function as you traditionally would with a machine, Delrin, and in turn use that CNC machine for producing metal parts that are going out the door versus supplementing what's happening inside the shop.
Nick, are there any industries? I know we talked about healthcare a little bit with the parts, but any industries that you're seeing that are really adapting 3D printing faster than others?
Yeah, so the automotive industry is growing by leaps and bounds over the past 2 to 4 to 5 years. And yes, there is some end use part application, but what they're really doing is upgrading their assembly lines. And when the assembly lines change, you have to change all the, and I continue to go back to this, you change all the jigs and fixtures and everything out. So they're upgrading and adding a number of these 3D printers, and they've got fleets of them, right? Where you've got 4, 5, 6, 7, 8, 9, 10 3D printers, and all they're doing is printing out supplementary assembly tools and fixtures and end of arm tooling and things like that when they need to change what they're manufacturing or assembling on the shop floor. So automotive has been growing by leaps and bounds. We talked about medical. Medical continues to grow with what we're able to do from a material standpoint. We've now got a bone matrix and a tissue matrix and a gel matrix that helps simulate what our skin feels like. Same with bone. When we're printing some of these models, you can say this patient is 75 with osteoporosis. Give me the density of bone that they're going to use. Now, we're not printing any material that's going to be an implant or that's going to touch skin for over 24 hours. But what they can do with that is they could practice that surgery with the bone. If they were going to drill into it, they can drill a screw into that bone and simulate how that bone's going to react. So I think what we're doing on the medical side is just amazing. Aerospace has been down for the past year with the pandemic, but they're slowly but surely coming back. And aerospace has always been great for us and our FDM technology We have FST certified materials. That means they're flame, smoke, toxicity proof. They can go up in aircrafts as end use parts. Now, we're not printing any structural components for these aircrafts, but we're doing aircrafts interiors. No one's manufacturing a million planes. Everyone's placing orders of 3 to 5 to 10 to 100 planes. So it's perfect for 3D printing because it's short run production. So think of the ducting that goes through an aircraft. I've got an example of that. I'm going to grab real quick, sorry. But printing the ducting that would go through an aircraft. This is an Altem part that that we've 3D printed, or just the little nozzle on top of that you control the airflow at your seat. So things like that on the aerospace side of things, huge applications for 3D printing. And then, you know, we're always going to have consumer goods and consumer products, and designing kids' toys or baby bottles, or breweries and beer bottles, Anheuser-Busch, right? So there's
Now,
a number.
Nick, did I see a shoe on the shelf when you were,
Yes.
Can we see the shoe up close?
Yes, yes, I'll go grab that. So this was, you've got a rubber-like sole, but you can really envision what is this shoe going to look like before you go through the traditional manufacturing methods for something like this.
So Nick, is that shoe actually wearable? I mean, somebody could put it on their feet and wear it out?
Not this one. There are technologies out there that are working with companies like Adidas and Nike that are printing parts of the sole. They're all printing parts of the shoe that are being used as end use parts of that assembly of the shoe. This example, this is not wearable. And we don't really have anything that we would recommend wearing right now. But we're getting closer and closer, I can tell you that.
Yeah, I see. And Roger, it looks like you have a question as well. Nick, it seems like this would be really applicable to the fashion industry, where so much is again dependent on prototyping and getting things from overseas. It seems like companies like a Nike, where you can actually go online right now. I could create my own Sarah Scudder shoe and have it at my door in a few weeks. It seems like this is something long term that could be used to customize any apparel part that you could imagine.
Absolutely.
Roger, did you have a question? It looks like your hand is raised.
Actually, he answered. I was going to ask him to show that vent because, you know, it is a production process for the vents inside an airplane. Like I said, nobody orders 1,000 airplanes; they order 100, baby. And when he talks about the jigs, my son-in-law is actually a chief mechanic at Boeing, and that's what they do. Is if they have something that is screwed up or messed up while they're building a plane, oftentimes they have to create a unique part or a unique jig to create the tool to fix whatever they just messed up, and they only need to make one of them. So, you know, it's an ideal way to do that for those applications. But the technology of this has just ramped up so fast in the last 10, 12 years. I'm just curious, you know, what's going to happen 10 years from now? Your comment about, you know, 3D printing a shoe, you know, they're 3D printing houses in China right now out of concrete. You know, so what's the next? So it's just going to be really interesting to watch. And Nick, I guess my question would be is, you know, looking 5 or 10 years out, what do you think we're going to be doing with these things?
You know, the technology is going to continue to advance. The material capabilities are continuing to improve. Just looking back at what we've done in the last 5 years, sometimes I equate this type of technology and how fast it's moving to what we've done with cell phones over the last 20 years, or rear projector TVs to LCDs and LEDs and all of that. We're in the same kind of trajectory where the technology is continuing to evolve in the material capabilities and the speed and what we're able to produce. It's changing the way that we design things. It's changing the way that we see products, because yeah, you're getting to the point where you're able to 3D print some products, whether it's in metal or in some of these other materials that we've talked about in small quantities. The shapes look different because it's an additive process. It's not a subtractive process. So you can think about, you're not taking a block of plastic or a block of metal and subtractively machining away that block to come up with that shape. You're adding materials. So you can have a lot of these unique shapes and designs that you traditionally wouldn't have. I think I've got a metal design that I can show you guys to kind of give you an idea of what I'm thinking about and what I'm trying to describe.
And Roger, I'm glad you touched on the 3D printing house example. I've seen some really cool videos of people actually showing the creation of that, and I want to get Nick's insights. But I mean, the fact that in our lifetime, people may have neighborhoods built out of 3D printed houses is just remarkable to me.
Yep. Can't find specifically what I'm looking for, so that's okay. We can carry on.
So Nick, we've got a couple more questions coming in from the audience that I want to ask, but I wanted to touch on what Roger brought up about 3D printed houses.
Yes.
I've seen some pretty remarkable videos on LinkedIn recently and would love to just get your thoughts or feedback on what's happening there.
Yeah, so first of all, what they're doing is amazing. And if you think about it to a certain extent, it's not that crazy to be able to do. Traditionally, when you're laying concrete, you're putting up all of the different walls, and then you're throwing down just you've got your concrete dropping everything down. So they've just found a way to extrude that concrete in a much more controlled manner, and are able to build houses with way less, I guess, materials required. I don't know a ton about that technology, other than the fact that what they are doing is amazing. And I think things like that are going to continue to evolve as well, where you might see in the future that they're not even using concrete. Maybe they're using different materials that they're 3D printing in the house, whether it's wood or some sort of metal or whatever it may be. I think that's a trend that we're going to continue to see.
I just imagine an entire house built from the 3D printer, including all the furniture, all the parts. I mean, that I think is going to happen in our lifetime.
Yep. Yeah, like the Jetsons.
You know, it's interesting because you know I'm using the wrong terminology, but one of the materials that they use to print with is basically air. Okay, because it's something that's going to be washed out or removed later on. So you're printing dead air space. So when you think about it, whether you're printing a house or something like that, you could actually print it. And if you use metallized components too, it might be possible to print the wiring, the plumbing, everything at some point in time, and have the thing fully operational when the print process was done. So that's, I mean, now that's out there for sure, but it's pretty cool. But hey, Nick, I had another question, because when I saw all those spools of monofilament line and everything, and I know they're thermal, but is that any application that's going to use recycled plastic? Is that where my plastic jugs are going when they recycle it? Is it coming back to you as monofilament line?
Short answer, no. There are some recycled material like a PETG or a PLA that I believe some of it is recycled. This material that we use in our 3D printers is not from recycled plastic. It's not that you can't recycle this material, but the material that we're actually using is not from recycled plastic.
That'll be an interesting thing to watch as the sustainability movement in the US progresses and more consumers are demanding companies provide sustainable options. What you guys are going to do in the material space to try to use recycled materials and contribute to the circular economy. So we've got a question from George. Nick, any thoughts on how soon a 3D printed bone could be available for surgical implant?
So, you know, here's another segment of 3D printing that I'm not going to say that I'm an expert in, but there are there are companies out there doing bioprinting. This is already happening where they're taking cells and growing in 3D printing parts. I'm not going to say organs, but they're starting to 3D print parts and skin and things like that. I fully believe that the technology is going to get there. Whether that happens in our lifetime or not is a story for another day. There is going to be some sort of leverage from bioprinting that we're going to be able to use in surgery in the years to come.
We have a question from Frank. Frank, thanks for being with us today. Happy Wednesday. His question is, who are the main manufacturers of 3D printers, both from industrial and a hobby standpoint?
Sure, great question. Thank you. What we're talking about today, at least the printers that I've shown in the parts, would be Stratasys. Stratasys is probably one of the, if not biggest, 3D printer companies out there on the market. Another competitor would be 3D Systems. 3D Systems has a lot of different 3D printers out there. They've got SLA technology. They've got a multi-jet technology as well. There's a company called EOS. They do SLS style 3D printing. And they've got some metal capabilities as well. We just acquired, Stratasys acquired Origin One, but that would be the DLP style printer. Competitor to that would be Carbon. Carbon does DLP printing also. And then there's X1. X1 is one of the leading metal OEMs out there as far as manufacturing metal 3D printers. They recently released a new office-friendly metal 3D printer. And then they've got more production-grade metal 3D printing as well, but they've been around for about 25 or 30 years.
So Nick, from a hobby standpoint, if I go on right now and Google 3D printers, I can find printers in the $200 to $300 price point. Are there any of those that you've used or recommend if somebody just wants to sample some things in their home?
Yeah, so I'm not as familiar with those. I think MakerBot offers some great entry-level 3D printers. There are, it's hard to say what you're going to get from some of those at that price point. I think you're going to find some good things and some bad things. But if you're buying one of those printers for in your home, I think those are the type of people that want to be able to tinker and play around with it. It's a hobby. So tinkering with a machine like that, that's fun, right? So it's hard to say that you're going to go wrong with anything in that price point for those types of uses. Do your due diligence, read the reviews. That's the beautiful thing of where we are in 2021. There's plenty of reviews on anything that you want to buy. There's tons of information out there. And that's what we see a lot with our customers today is, we're seeing people do a lot more research on the front end and way more educated on everything before they come to us to start investigating any type of purchase.
So those that are on the call that are in procurement or supply chain and are potentially interested in buying printers for their companies, what's involved with, so you mentioned some of the main manufacturers of the printers. What else is involved? Is the software a separate purchase? Who provides the software? Does that come as part of the printer? And then is there any sort of pilot or testing that companies offer before somebody just goes out and makes a purchase?
Yeah, great question. So majority of the software comes with these 3D printers. If you're in an industrial design firm and you're wanting to do some of this texture wrapping and you don't have KeyShot software, we can offer that. That's kind of an a la carte thing. But majority of our customers at that point already have that software. So as far as taking your native CAD file, we provide the slicing software that you would import your native CAD file in to set up the print and send to the printer. So there's no additional software that typically needs to be purchased. And by no means would we expect to sell a $75,000 printer with just a phone call. One of the things that we typically offer is we really roll up our sleeves. We really want to better understand what challenges our customer is facing, what applications and use cases would make sense for 3D printing. They might have one idea. We'll try to identify maybe more ways they can leverage the technology. And we work with them to identify the right materials, the right machine, and all of that good stuff for the application that we're trying to address. And then we'll print those parts. We'll let them test those parts and see how those parts react in the field. And at the end of all of that, hopefully they get to a point where they're able to make an educated decision if it makes sense to do business.
And then where are you seeing people place these machines? I mean, are people putting them directly in the warehouse and making it more of a part of an assembly line? Do they need to be more inside, like you have more of a formal office?
They can be, it depends what machine it is, first of all, but for the most part, they really can go anywhere. You see that I'm just in a standard office building here with some of the printers that we're running. You can absolutely put them out on the shop floor. You want to have a clean environment that they're going to be running in, because they're going to have air coming in and coming out. So as long as your shop is for the most part clean, they can be out on the shop floor or in the warehouse. As long as, and then in the warehouse, you want to make sure that you've got some sort of temperature control. You don't want these machines out in 95-degree weather when it gets hot in the summer. But yeah, as long as you're in a temperature controlled environment, they could be in your warehouse, they could be on your shop floor, they could be in your office, they could be on your desk, depending on what size they are. So yeah, options are endless.
All right, good. So a lot of flexibility there. Roger, we've got about 5 minutes left. So wanted to see if you had any final question for Nick as we wrap up today.
No, not so much question, but when I see this equipment and it's all digital, it just reminds me of when we first started seeing digital presses hit the market. And the first ones were fairly simple. They were black and white. Then they could do some color, and it was dry toner or wet toner. And there were limitations, and all that expanded into all the wonderful stuff they're doing now with soft touch coatings and all that. So to me, this is just another digital print process that in its growth, we're going to see more new substrates, more different durometers, more different densities, more, they could do the entire PMS book already. So that's pretty cool. And I think you're going to see that, and just the processes that this can be used for, just like digital presses brought us all sorts of new markets. This is going to do the same thing. It's just we're on that upward trend, and we just don't know where it's going to go yet. So it's super exciting to watch. And that tour yesterday, Nick, I got to say you blew me away with that. That was awesome.
Awesome. Well, thank you.
And Roger, I think it's important to really address the financial implications of how much money machines like this can save companies, not only from having to, go out and buy other types of expensive equipment or prototypes, but the amount of money that can be saved by freeing up inventory. So companies don't have to order significant amounts of inventory, tie up cash flow, and then you have the whole obsolescence issue where you don't actually use it and then you have to destroy it. By being able to produce things on demand, it's a significant impact on the supply chain and being able to get things out the door quickly without having to have large amounts of inventory.
Very true. Very true. Similar to old style printing. If you can keep less in the warehouse or nothing in the warehouse, it's better. And even though these machines aren't necessarily designed to produce mass quantities unless they happen to be small, like Nick mentioned, that one machine they were showing that has a large flatbed basically on it. If you're talking a small piece, you can do a lot of small pieces. And even if it took 5 hours, when you do the math by it, the per piece time is not that much. That's going to continue to move forward and get faster, and the beds will get bigger and the machines will get bigger. So all this is just going to keep ramping up. So just like digital print, when it first came out, you could, it was only reasonable to do 1,000 sheets, because anything over 1,000, you had to go offset. Well, now you see people doing 100,000 pieces digitally, and it's no big deal. And that change has happened very, very quickly. So we're going to see the same thing happen with this technology. I think you're going to see in 5 or 10 years, these are going to be very, very common, and they'll probably be more common in households for, printing some piece that you want. Maybe you're going to print silverware to see what color you like.
Nick, closing thoughts from you, and I want to see if there's any other cool thing from the wall that you want to show us. I think the shoe was my personal favorite, but is there anything else that you think is really unique that you want to show us?
No shock here that you picked up on the shoe, Sarah.
Give me 1 second. Let's see here. We've got some good stuff.
It would be fun to, Roger, you're lucky you got a tour. Oh, cool. Here we go.
It was cool. It was
So
cool.
I think this is interesting. And this was FDM. So, and then we vapor smoothed it. But we had a client that this was like not a marble, but it was like a concrete statue outside of their building. They had 2 or 3 of these, and one broke. So we 3D scanned it, 3D printed it, and then they used this in their manufacturing process to create a new one to replace it on the building, right? But this guy is
It's a little scary looking, Nick.
a little bit. It looks like it's from Ghostbusters or one of the gargoyles. I don't know. And then we've done some artwork, some 3D printed artwork, which I think is pretty neat. And then I think just like the realism of this frog. I think he's kind of fun. And then one last thing I'll show you is this is just a 3D printed like mold block for like if you wanted to do short run injection molding with a 3D printed part. I think that's pretty cool as well.
That mold part you showed with the paper pulp molding, I think is incredibly cool because we both know the same gentleman in St. Louis that owns a company that does that. And with more and more people buying stuff being shipped to their house, all that packaging and that internal packaging and support structure changes with however that, whatever's going in that box. So I think that is an awesome application. And I think the guys that are doing that pulp molding got to be crazy about this.
Yep, absolutely. Yeah, no. Well, no, I appreciate everyone's time. Thank you for inviting me today and allowing me to participate. I hope I addressed more questions than created questions in regards to 3D printing. And if there's anything anyone has as far as questions moving forward, feel free to send me a message on LinkedIn, and I'd be happy to help.
Awesome. Well, I want to thank Roger and Nick for joining me today to talk about 3D printing, something I'm really interested in and plan to follow closely. I want to thank ISM New Jersey for producing so much great content and always going and kind of coming up with new and innovative information to share with the procurement community. So Kathy and team, thank you again for hosting and asking us to come and do a show and tell today. Feel free to reach out to myself, Roger, or Nick on LinkedIn if you want to continue the conversation, talk more about what's happening in the printing space. And Nick is just a great resource and wealth of knowledge for anyone who has specific 3D printing questions. So with that, we will wish you a wonderful afternoon. And Kathy will be sharing this recording in the next day or so. So if you want to rewatch it or share it with colleagues that weren't able to join us today, that will be available. So have a wonderful afternoon. And thanks again, Kathy and team.